This video will show the data service platform which makes smart technology use data in smart way. As you know, artificial intelligence, Internet of Things, big data, augmented reality, virtual reality are categorized as smart technology. The common ground of these new technology is to use raw data as their input. It means the quality of these smart technology depends on the quality of input data. Cnix has tried to supply high-quality data to consumers, and finally Cnix has become to be able to provide data service platform. Data service platform will supply the standardized live data, which are gathered from industrial devices, to applications of artificial intelligence, Internet of Things, big data and cloud. Especially, data service platform will supply the chunk of data, which is being archived with ultra-high rate by data service platform, to big data system. In other words, data service platform makes front-end services use the raw data in smart way. This data service platform has been applied to various sites for decades, ensuring stability and reliability. Heavy industries such as POSCO, Korea Petroleum Corporation, Big Science of Pohang accelerators, environmental fields such as waste incineration plants and water treatment plants, SOC fields such as subways and airports. In addition, by connecting numerous individual devices and integrating systems, we are delivering data at high speed to various users' applications. First of all, let's look at the simple concept in system configuration. The data service platform combines data collection from hardware such as sensors and actuators, process engineering using data, high-speed data storage, and system integration to supply data to various service apps. It can also return the results of service apps back to the hardware for feedback control. Then, let me show how this data service platform is connected with the Industry 4.0. Smart city, smart factory and industrial ecosystem. These words would be the word that comes to mind right away when talking about Industry 4.0. So far, smart cities and smart factories do not seem to mention how to use data in smart way, although they would emphasize on smart services. To implement smart services, the data used as input should also be available in smart way. In fact, looking at the construction of front-end services, it is true that there is a problem with collecting data to use as input. At least, it seems not easy. As a methodology for this, we propose a data service platform. In the construction process of the Industry 4.0, the front-end services such as artificial intelligence, the Internet of Things, big data, and the cloud often connect directly with the hardware, or in big plants whose level of automation is high. Such service apps are usually connected to the data of the hardware with using an OPC server or RDB database. This connection method is somewhat inadequate to provide better services for legacy systems and smart services for large systems. If the front-end services are directly connected to the hardware, other services may not be able to share data, and the network traffic with same purposes may be heavy, so the system can't work well in some cases. When using a commercial database, data sharing problems can be solved, but there is a problem that a live data cannot be obtained. In large plants or high-speed precision processes, it is not easy to use data for feedback control. Data sharing using OPC server can get a live data of relatively high speed, compared to commercial relational database, but there are still many industrial equipments and devices that do not support OPC except big branded equipment. After all, these three typical ways of connecting services with data are not perfect solutions for the integration of large plants or small group factories, because the front-end services of the Industry 4.0 have a wide range of hardware and services. The bigger size of system gets, the greater the need for new alternatives. The data services platform is a perfect logical separator between the hardware and the applications for services, moving away from traditional system configurations. In this configuration, applications on higher level services and system don't need to know about hardware on lower level in system. They only need to know is the physical meaning of the data provided by the data service platform, so they can focus on the functionality and quality of the services. It also supports interfacing with various devices at lower level and system for the front-end services, so that data can be collected and archived at high speed, and loaded onto memory with the structure of standardized model, and that all service applications can take data easily. It also supports process engineering, connecting all devices which are connected to the data service platform, in its own engineering environment. Process engineering is sometimes called as a rule. It provides a variety of control libraries to support the environment in which software-based DCS can be operated. It means there is no need to implement the complex logic for the control process in the service applications. The data service platform is applicable not only to the manufacturing process, but also to civil systems such as smart cities. In the case of smart cities, the variety of hardware and the number of devices which are taking part in smart city are bigger than the manufacturing process, so if you don't have separating layers in system like data service platform, you will have a lot of difficulties. So, with some examples, I'll explain why you need an independent configuration of a data service platform. As shown in the figure, let's assume that a particular system and front-end service are directly connected. As time goes on, the aging of PLCs, sensors, and actuators will progress, which may cause some hardware to fail or be replaced. At this point, if some of the devices connected are changed to different models from different manufacturers, you should consider whether there is any impact on the logic that has been implemented, tested, and operated in service applications. Changes or additions to hardware configuration mean that scan time of data, metadata, types of data, etc., are changed and added. This change in hardware configuration cannot be predictable when designing service applications in the first stage of building systems. This situation can't guarantee the homeostasis of logic in the front-end service applications. If the service applications in system need to run a non-disruptive system, there is a greater risk. If this system had a data service platform, it would look like the picture you see now. In the data services platform, the standardized data with a unique name on network, logically separated from the hardware, is always in memory, ensuring that can guarantee the homeostasis of the once tested logic. In the front-end service applications, the handling of the changed or added hardware will be controlled by the data service platform, so that already implemented services can work in 24 hours a day, 365 days a year without stop. Collected data should be archived in time domain for pattern analysis by the front-end services. However, as the system grows in size, some new requirements for archiving systems arise. First, it shall be able to archive, with the rate up to megabytes of events per second. Second, it shall be able to distribute the repository of archiving, and cluster the distributed repositories easily. Third, it shall efficiently archive data from various hardware, because even though the data has the same physical meaning, if the equipments for measuring or control physical amount is different from each other, the scan time, linearization of the data and so on, will be different. There will be many challenges in designing these requirements on a relational database. However, the data service platform can solve this out. As you can see, the archiving system provided by the data service platform builds a file-based database using memory. Currently, it was proved to archive data with a rate of 18 mega events per second. Depending on the equipment specifications, the archiving rate may be faster and faster. In addition, the individual data, archived in the distributed archived system, can be integrated and searched by the name of the data, with using the data link function of data service platform, and all data can be saved as the form of standardized data structure, because archiving system is configured on the data service platform. The next step is to build a system that provides services such as artificial intelligence, the Internet of Things, big data, and the cloud. By integrating systems nationwide, it is probably the case that the facilities operated by each municipality interlocked with each other, or manage cases such as national disasters. For example, of the case for water resources, in the regions of the Nakdong, Kyum, and Han rivers in Korea, the managed water supply chain is not only managed by one municipality, but also through various municipalities. The same goes for the electricity power grid. When dealing with these national-wide utilities, how to classify sensors that measure the same physical quantity in different areas is a very important issue. Taking the electricity power meter as an example, the traditional method would probably give a long serial number to the sensor in Yeouido, Yeongdeungpogu, Seoul, and another long serial number to the sensor in Nampo-dong, Yeonggu, Busan. If you use this method, you need to query the database to find the information of data with a long serial number, which makes that sensor data and information are not easily recognized and shared by many other organizations and services. Inquiry by the program from the database is not a problem in itself, but when people are working, there are times when you have to do cumbersome procedures. Inside of Data Service Platform, it gives each data a unique name on network. As you can see, the unique name of physical location of the sensor makes it easy for anyone to recognize, remember and share the information of data. As systems are built up, there are always some unexpected things happening. From an engineer's point of view, it's very embarrassing to add unpredicted facilities to system, because there may be in situations where the system design itself needs to be changed. Another case is when a new system is added after the system is finalized, which can be the worst situation for both system users and suppliers. But you don't have to worry if you install the Data Service Platform to build your system, because the Data Service Platform completely separates the system layer of hardware from the layer of service applications. Whatever new system is added or whenever it is added, the new data on the Data Service Platform is all standardized, and new hardware can be added in system without system stop, and regardless of the logic of service applications. It is not difficult to implement front-end services for one or two facilities. However, integrating the system at a factory, nationwide, or worldwide is not easy. With legacy system configurations, you may have to give up a lot of data. Because of the size of system, it means that you can lose reliability of the output from the front-end services. Even with a given reliability, there may be many obstacles to feedback control. The Data Service Platform solves this problem very simply. Among the functions of the Data Service Platform, there is the function of data link between the data service platforms. Using this feature to expand the system, you can integrate the systems at plant level, at nationwide, or at worldwide, and no data needs to be given up by system scale. So, in the front-end services, data anywhere in the world can be accessed by its name. This ensures the reliability of output from front-end services and enables feedback control. If a physical network is well defined for system integration in global scale, the Data Service Platform can provide a better solution. Like this. The Data Service Platform will create a local data fog at the low level in the field as shown, and a live data from all connected devices will be put on the data fog. At front-end services, they can access data directly by its name. The cloud services have been adopted for industrial data recently. However, from the manufacturer's point of view, it's same that the data, in which all the information of manufacturing process is melted, is exposed to the outside. However, by implementing a cloud with a form of data fog in the field, manufacturers can avoid security risks caused by the introduction of an external cloud system. This reduces the cost of adopting edge computing for feedback control. This is due to that the data fog implemented at the shop floor supports the engineering environment. In other words, the Data Service Platform is an industrial data fog. In general, a cloud can be defined as the highest concept in terms of a network, because it exists on the internet, whereas a data fog is a collection of data formed in network closest to field. It means that they are opposed to each other in view of the network topology. In the previous video, we used the expression of feedback control. Let me explain what this means. Looking at the construction of the Industry 4.0 so far, almost all of them focused on building front-end services. Somehow, individual service application uses the collected data to analyze and serves the results to users. However, there is one thing missing from building a smart system. It is feedback. Some front-end services provide a rule function for feedback control, but there are limitations that cannot represent various processes in the field, and they are not prepared for the high-speed feedback operation. However, the data service platform provided by Cnix supplies an integrated engineering environment to support high-speed process control and various libraries for control, and it makes the analysis results from front-end services work directly in the field. Using Data Service Platform, once feedback is completed, the perfect cycle of smart system can be set up, from data acquisition and archiving, data analysis, decision to feedback control. We can say that it is a smart way to utilize data from the field. Now, let me show what you can do by applying the concept of Data Service Platform to Smart Factory. Take a big-size plant as an example. As you can see, there is a big plant, composed of dozens of unit factories. Configure Data Fog on Data Service Platform, so the data was put in Data Fog, and the devices and equipment that produce the data are connected to each other by the Data Services Platform. Of course, each data has a different data type, scan time, etc., and each data is updated from at least several milliseconds to several minutes with the uniqueness. After configuring the Data Fog in the engineering environment provided by the Data Service Platform, if you program as you see, all the processes from raw material shipment to end product shipment are synchronized and integrated. There is something that couldn't have been done until now, but can be done from now by this. Let's see. The data of the entire processes is present in the local data fog, while maintaining the characteristics of individual datum, and the data for services such as artificial intelligence, the Internet of Things, the cloud, and big data is standardized in the local data fog. It makes the final service applications to be able to analyze all the processes from raw material shipment to end product shipment at once. In a word, the front-end services implemented on this data service platform can be an operating system that can run the entire plant. It is the moment when the factory becomes a machine. In particular, when data services platforms collaborate with artificial intelligence, what is now unimaginable will happen. With the data service platform, when all the data of all processes are in the data fog, artificial intelligence can learn the process algorithm for the whole processes in addition to each unit process, and do the reverse engineering. From this collaboration, the whole processes can be packaged in one package of software. This means that the manufacturing processes can be copied and pasted, which reduces the commissioning period when building overseas plants or exporting plants. As you know, there is a huge difference between knowing an answer and unknowing an answer. When solving a problem, artificially trained and reverse-engineered plant software by artificial intelligence will answer many questions during commissioning and design. You can even use reverse-engineered software to simulate the entire plant processes virtually before starting build. Now, there might be a question as to whether this is not possible using the existing solutions of Industry 4.0, rather than the data service platform. Of course, it may be possible, but it is not easy with their concepts. First of all, the data is not standardized. With external cloud services, you can't use high-speed live data for monitoring and feedback control or high-speed archiving system. If the data couldn't be archived at high speed, a large amount of data must be given up. It may affect the accuracy of the process pattern analysis by artificial intelligence by a great deal, because control system should not come out of probability. Now, let's apply the data service platform to smart cities. Until now, smart city has developed a lot, but it has focused on the smart service of individual facility, not a smart city for the whole city. We will show a new smart city for the next generation. Let's imagine this scenario. All the facilities in the city are integrated and connected to each other. Of course not at this time. For example, suppose heavy rain falls in the Gyeonggi area in Korea during the summer rainy season. At this time, the facilities of Seoul City, which are connected to each other, start to operate themselves in according to the optimized program. Rainfall from Yeouido, Yeongdeungpogu, Seoul, is continuously monitored and sends a flood signal to KEPCO as soon as it exceeds the limit of the stormwater treatment system. At the same time, The flood signal is sent to the Water Resources Corporation, which automatically opens the gate for the downstream of the Han River Dam. At the same time, it is sent to Seoul Transportation Corporation, opening all drains connected to the basement and stopping the subway going to Yeouido. The scenario I've talked about so far will not be done by humans, but by the programs for flood which are already prepared on Data Service Platform. The reason why it is imaginable is that all urban facilities are connected in a data fog, as if the city was alive. Here, as with Smart Factory, let's consider the collaboration of artificial intelligence and data service platform. If all the data of cities' facilities are on the data fog by the data services platform, then standardized data can be easily used by anyone. It means that the environment where many services using artificial intelligence, the Internet of Things, big data, and the cloud can be conceived will be created. In this environment, AI will be able to learn the optimized city operations. Based on this, a city with a data service platform is no longer just a set of buildings, but living organism, and not only hardware evolution, but also software evolution. And when we export smart cities abroad, we no longer only export hardware like construction, we can now export software. This is due to that data service platform can make cities to enable to be copied and pasted. Now, let's verify the data service platform mentioned above and the feasibility of data fog through projects executed by Cnix until now. The system configuration you see now is the electricity power microgrid system. The data service platform collects data from the electricity power meters in real time, constructs data fog, and provides chunks of data to big data systems, the Internet of Things, and the cloud with high speed. Why did the data service platform was implemented? Even though the big data system and the cloud diet can collect the electricity meter data directly, the reason for this is that the update rate of the electricity power data produced by the 60 electricity meters is too fast. The data to be collected and archived is up to 3,840,000 double words per second. This is not easy for big data or other relational databases. So, the data service platform temporarily collects and archives a large amount of ultra-high-speed data, and supplies chunks of data to big data system. Currently, Data Service Platform is archiving data for 3 days. For the IoT system, a live data is transmitted after calculation of statistical operations on the Data Service Platform, which enables the IoT system to concentrate on its function, not on collecting data. In the case of a smart city, it is very rare to need high-speed data archiving for one device. However, in the case of social infrastructure such as electricity power data, it is often necessary to archive a large amount of data at high speed. In most cases of smart factory, there are many devices whose data is needed to be archived at high speed. What I want to talk about in this system is the performance of data service platform to archive large amounts of high-speed data, and currently Data Service Platform is archiving events at 3 MHz in this project. Cnix, from 2015 to 2017, undertook the project to integrate 15 public main facilities and 11 regional public systems on nationwide. What I'd like to talk about in this system is the integration of large-scale systems across the country, and the integration of many heterogeneous systems. In this public services, about 27 global companies have been supplying control equipments to related public facilities in Korea, and about 300 models are supplied as devices. This means that there are over 300 types of communication protocols for communicating with the equipments, and even though the data have the same physical meaning, the characteristics of each data such as scan time, data type and another metadata are different from each other in according to suppliers and models. This project demonstrates that the data services platform can integrate more than 1,300 heterogeneous devices of 300 types on nationwide in single-entry server. The various service applications that do control services at front end do not have to worry about which provider measures what physical quantities, what kind of protocol, what data type, and so on. They just need data names to get the data values and to know the physical meaning of the data. It makes service development become more various and easier. With the live data in the field and an easy-to-use environment, customers use these data to plan and develop many other new services. This shows that a live data is a fundamental premise of service development. The system diagram you see shows the system for platform screen door for 160 subway stations in 4 lines. The project demonstrates that the data services platform can integrate city facilities, create data fog, and feed data to various service applications. Due to the nature of the subway, it is important to be operated without stop in rush hour, and it generates a huge amount of data at high speed as much as the manufacturing processes of large factories. Moreover, in relation to the safety of passengers, the system also has to be reliable. The new stations are still being added to the data services platform without system stop. The system, which was supplied in 2008, has been in operation. The period of non-stop operation is up to 12 years. The safety of people should be the first requirement for Smarty City. With 12 years of non-stop operation, this project proves the reliability of the data service platform. Cnix is responsible for the one line among the big scientific experimental equipments. The line is about 30 meters long, but it consists of hundreds of measuring and control devices. The problem is that all measurers and control equipments need to be synchronized to each other to control the light path to strike the sample exactly. How can you synchronize a large number of heterogeneous devices, communication protocols, individual scan times, and various inputs and outputs? As you can see, the integrated engineering environment, supported by the data services platform, makes it simple. Various inputs and outputs from various instruments can be programmed like this. The abilities of synchronizing, integrating heterogeneous systems, and data fog allow us to say that data services platform can do the functions as a key system layer in any large factory or city. Smart CCTV monitoring system. The system you see now is a smart CCTV monitoring system supplied to local government. In this system, Cnix was responsible for distributing each CCTV video to responsible monitoring terminal, in according to the scenario which was prepared by individual staff for monitoring. The total number of monitoring terminal is up to 80. This system, patented in 2019, is the first user scenario-based video distribution system in Korea. At the time of completion, the videos from 8,000 CCTV cameras were being supplied to the responsible monitoring terminals, in according to the user scenario with using the information analyzed by the AI system. Video transmitted from each CCTV is updated with a rate of 10 frames per second. If 8,000 cameras had been installed, 80,000 images should be processed in 1 second. In order to distribute such fast images using the analyzed information properly, the high-speed parallel data processing system is required. The data service platform, supplied by Cnix, has succeeded in integrating and distributing the videos and information of 8,000 CCTV cameras, with just only 3 servers. The additional point to note with this system is that the data is being archived at 18 MHz. Perhaps it's faster than any other archiving system ever, and it's an example of why data service platform is needed for smart cities. Now, let's talk about business, which can be powered by the data service platform. iOS and Android. If you pick devices that dominate the world right now, it will be definitely smartphones such as iPhone and Android phone. It's no exaggeration to say that the world began to become mobile after Apple had announced iPhone. On iOS and Android, there are a lot of applications. Daily lives of people are changing a lot by the services of these applications. Even the world-class services has been often appeared. In short, the business of user service applications is on the rise and fall in iOS and Android. iOS and Android, we called them OS. The ecosystem for applications was formed on these OS. Now, let me talk about the data service platform. After having been built data services platform, new services began to be conceived. The first example is the reverse engineering service, anomaly detection service, and medical image analysis service. These services require high-speed archiving of data. After having been built the data service platform, a company, Specialized CCTV, launched a new smart CCTV monitoring service. It is also a service that requires the high-speed parallel processing of data. After having been established a data service platform, a blockchain company is planning to develop a tracking service for data of manufacturing. This service requires standardized data from various controllers and sensors in field. After having been established data service platform, Fine Dust Control and Monitoring Service has been commercialized by a big company. It's a service that requires a lot of instrumentations, high-speed data archiving, and synchronization of heterogeneous equipments. After having been built the data service platform, 3D company wants to provide 3D graphic service for factory automation. It is also a service that requires a data fog. As such, new services are conceived on the data services platform. It means that industrial ecosystem is naturally being built by the data service platform. For a moment, let's look the inside of computer we're using. Inside the computer, a circuit is drawn on the motherboard, and hardware devices, such as communication chips, memory chips, CPUs, and hard disks, are placed on motherboard and connected to each other through circuits. And to run these hardware devices, the operating system of Windows, Mac OS, Linux, etc., must be installed. On a computer, OS collects data from various devices on the motherboard and makes application programs such as Internet browser, file browser, and Office software use the data in smart way. From this point of view, smart factories and smart cities can be compared with configuration of computer. The circuit can be replaced by network, which connects utilities such as platform, screen door of subway, and CCTV for security. And we are preparing front-end services, such as artificial intelligence, the Internet of Things, and big data. In addition, the data service platform logically connects public facilities on network, collects data, and makes an environment where front-end services can use these data in smart way. In other words, data service platform plays the same role as computers OS in the system of smart city and smart factory. For example, let's imagine this case. Let's say that there is a building that is well automated. However, suppose it is a building without an OS, such as a data service platform. One day, if a new building that supports various state-of-the-art smart services has been built, next to this building, a landlord would strongly ask a building manager to make her building support smart services to increase the value of her building. Perhaps the building manager will be in trouble to find interfaces and solutions to support new services. Even the cost for building upgrade will throw him in panic. However, if the building has an operating system, such as data services platform, a building manager doesn't have to worry. If new hardware should be added, the hardware can be connected to the data service platform on network without system stop, and run the communications program on the data service platform, with using the integrated engineering environment, as if the drive software for new hardware were installed on the computer. What have to be done by new service providers is using the data by its name from the data fog, supported by the data service platform. Distribution. Distribution is perhaps the most basic platform in industry. Nowadays, distribution includes not only the physical movement of goods, but also the flow of digital data. A good example is the Amazon online store. Amazon can be seen as a company that distributes data by delivering producers' information to consumers, and by using consumers' consumption pattern to personalize producer information. In other words, it can be said that data distribution is Amazon's revenue model. The same is true for industrial data. The industrial data, like goods, will be delivered from data producers such as sensors and actuators, to data consumers like front-end services. If the feedback is included, the various equipments and devices in the field can be both of data producers and data consumers at same time. In other words, the marketing of data service platform I've talked about so far can be done with a business model like Amazon that can handle data distribution in these industries. Now, The market for OS concepts, which makes the front-end service enabled to use data in smart way, has not yet opened. Data Service Platform can be marketed with the concept of OS for Smart Factory and Smart City. What's more, it can also support industrial ecosystem. We have secured its functionality, reliability, and stability as an OS for building smart factories and smart cities, by doing projects and range from the largest plants to large public facilities and security systems of local governments. As introduced earlier, the difference between existence of a system that acts as an OS concept and absence of such system is enormous. Soon, this market will be opened. How about you join us to make a market first and grow it with Cnix? Thanks for watching this video.